Welcome to week 7 of ELE4RSD. This week we'll be looking at a whole lot more forward kinematics examples and practical examples where we're putting these in a definite Hardenberg form and solving them and working out what the end effector position is in reference to the base frame. By way of revision, remember we've got in forward kinematics we've got a series of rigid bodies which are links connected to each other by a series of joints, either revolute joints or prismatic joints. And if we know all the angles and displacements of those particular joints and our linkages, we can work out what the end effector position is with respect to the base, or relative to the base coordinates. And that's what we're doing in forward kinematics. We're computing the end effector position or pose given all the joint angles. Remember we had four main parameters that we're dealing with, the Devener-Hardenberg parameters. We had A, which is the length of link I, and this is fixed unless the robot's actually modified in some way. And it's essentially the distance along xi. We then have alpha, which is the twist of link I. Now this is once again fixed unless the robot's modified, and it's the angle about xi from zi minus 1 through to zi. So the twist around xi, the new variable for the x coordinate, from zi minus 1 to zi. We then have di, the link offset of link I. And this is something that we can use as a prismatic variable if we're using a prismatic variable. This will be the length of the prismatic variable, how far it's extended out, and so on. Otherwise, it can also be used as the distance that we've moved from our previous axis to our current axis along zi minus 1. Finally, we have theta. This is the joint angle of link I, and this is what we generally use for our revolute variable, but it's also the angle that goes around zi minus 1. The angle between xi minus 1 through to xi. And once again, remember, if we move any of those angles, either alpha or theta, in a clockwise direction, it's negative. If it's an anti-clockwise direction, it's considered positive. And then finally, we have our transformation matrix there that we use, and we put all our particular values in. We've got our C's there and our S's standing for sine and cos. We put our values there, we can chain them all together and compute our final end effector position based on our base coordinates, or any one of those coordinates, by how many we multiply together.